All right, welcome back, every one of you. I'm so glad to have you for another episode. All right, episode 3. Remember, in episode 2, we saw the application of the two equations of the compound interest. All right, the fourth equation is applicable only when we have our rate to be constant. All right, of course, we know that in compound interest, the principal is always changing because the interest that was supposed to be returned to the beneficiary period-wise at the end of each period is actually reinvested automatically, added to the initial principal to increase it. So we don't have problem with that. So we know that the rate is constant. We use equation 1. All right. And when the rate is changing, okay, we use equation 2. All right. So we saw the application of both equations. All right, we have not seen a third scenario whereby a question will not conform to equation 1 or equation 2. And of course, we are going to look at that today because there are some instances where you are given a question. Of course, it will not conform to equation 1 or equation 2. Now, let me tell you one thing to do, or one general principle in mathematics. When a formula is being derived, please pay attention to the process of derivation of that formula, okay? To the explanation behind that formula, because it's not in all cases that that formula may be useful, all right? If you look at our equation 1 of the compound interest, it is derived based on the fact that your principal is being compounded. That means it's always changing. Then the rate is constant, okay? And the first year, you put in $100, you make 10%, which is $10, you add the $10, okay, to the $100, become $110. You use the same rate again for the second year, and so on and so forth. So that is equation 1. All right. So anything that is not in line or does not conform to this explanation, that means it cannot work with equation 1. That means even if you are investing $100 and all that, but the rate is changing, the rate for the second year is changing, then that is when we have equation 2. Okay. That is when we have equation 2, whereby the rate is changing, though the principal is still being compounded, but it's not compounded with a new rate. What of a situation whereby the question is deviating? It's a kind of a pseudo, if you like, a pseudo compound interest. For instance, in normal compound interest, nothing is being returned to the owner, the beneficiary of that money. The person don't receive a large period-wise, monthly, yearly, or whatever, depending on the agreement. Okay, that is the normal compound interest. You can also have a situation whereby, a compound interest whereby the owner receives some part of money, some part payment, may not be all the interest. It can even be more than the interest, because if the interest is average, then of course automatically back to simple interest, because it's simple interest where we receive the interest every month. So we can have a situation whereby the beneficiary will see part return, okay, part payback. It will be part of the interest, not the full interest. That means the money will be reinvested, or it can even be interest with some extra money, more than interest. So it cannot be, in this situation now, it has deviated from both equation 1 and equation 2. And this explanation is applicable to physics, to chemistry, to mathematics, to further math, any question that has formula. You must solve that. For you to use that formula, that particular question must conform to the principle of the derivation of that formula. If it does not conform to the principle of the derivation of that formula, of course, you have to now solve it step by step, stepwise. You have to now, that's what we call analysis. You have to now analyze it, to apply the principle or the conditions, okay, that is prevalent, which has changed it from the normal norm of using that formula. You have to now analyze it differently. All right, so that's what that's part of what you're going to see in this episode. Let's go to the classroom and see what I have for you today. Continuation of compound interest. Examples. We'll continue from example 5. Remember, we stopped at example 4 last time. A sum of money amounts to 500 naira in 2 years. And 540 naira in 3 years at compound interest per annum. Now, look at this question. It is per annum. So the rate is per annum. And of course, and our periods, our reckoning time is 2 years. That means every year. Okay, so it means that the rate and of course our R are compatible. So we don't have problem with that. That's settled. All right. So we have established that explanation in episode 2. Okay, we have to find the nearest whole number, the sum invested. So the sum invested, now don't confuse this sum with the normal total amount of money, principal plus interest. This sum is just a whole money, a whole lump of money was invested. Okay, so it was invested, it amounts to, okay, for it to amount to something, it means that it was something before. So that something before is the principal that was originally, the original amount that was invested. Okay, that means this 500 naira is now the amount. That means after you have made a profit and you add it to your principal. So we have identified that our amount is 500 naira in 2 years. Okay, what does that mean? Somebody intends to invest money and they have told the person, the bank told the person, you are going to make 500 naira in 2 years. Okay, at a certain rate. We don't know. And if you also invest that same money we don't know for 3 years, at the same rate, you're going to make 540 naira. What is the rate and what is the amount you need to invest? Okay, so now let's also do some elimination. I'm teaching you how to eliminate, know what to do, how to eliminate something that may confuse you in a normal situation. All right, which of the formula are we going to use? Now, of course, because the rate is constant, from here we are not told that the rate is changing. So it means that the rate is constant for the 2 years or for the 3 years. So we don't have problem with that. Okay, so that is settled. That means we are going to use our formula amount equals to P into 1 plus R over 100 raised to power n. So this is the formula we use. All right. Now I want to tell you that this question will lead us to simultaneous equation. Someone will ask how or why. The reason is that they say when you put your A 500 naira and your n equals to 2, you're going to have P and R unknown. Already when you are facing a situation whereby you are having 2 variables in an equation unknown, 2 variables, 1 equation, and there is 2 variables, 1 equation is not even possible. You cannot be solving, looking for 2 variables in 1 equation. Okay? Except it is possible to express them as a ratio. Then the answer will be a ratio and all that from you can use ratios and get the answer for those 2 variables. If not, it's naturally not possible. Okay, it's not consistent. So you need another equation to support the 4th equation. And of course, it's also when you insert your A equals to 540 and your n equals to 3. Then you now have the 2nd equation of P and R. Then you cannot combine them together. So that's how we know it's going to be simultaneous equation. So we now say when our A is equals to 500, okay, and our n is equals to 2. That implies we won't put them into this formula. We now have 500 is equal to P unknown, 1 plus R unknown, divided by 100 raised to the power 2, equation 1. Alright, we'd also say that when our A is equals to 540 and n is equals to 3, that implies that 540 is equals to P into 1 plus R over 100 raised to the power 3, equation 2. Alright, so now we have equation 1 and equation 2. What do we do? Do we do subtraction? Of course, the answer is no. Why? We use subtraction when they have the same magnitude. Okay, if you want to use elimination method, okay, to solve this problem, you can actually use subtraction addition if they will have the same magnitude and they will eliminate themselves, and 1 variable will be eliminated, because if you apply elimination method, your primary motive is to eliminate one of the variables, okay, by an operation, either multiplication, division, subtraction, or addition. So when we divide this P here, we cancel this P here, and of course that eliminates the P. If you subtract, they will still be here. But if you divide, P we cancel P, and of course you will now have only variable R remaining. Alright, so that's how we know we divide. So now say equation 2 divided by equation 1. We can do equation 1 divided by equation 2 so long as one of the variables should be eliminated. Okay, equation 2 is 540 divided by 500, both on the left hand side, equals on the right hand side, I have P For equation 2, 1 plus r over 100 raised to power 3. And on my right hand side of equation 1, I have p into 1 plus r over 100 raised to power 2. All right. So of course, when you do 500 divided by 540 divided by 500, we are going to have 54 over 50. So we have 54 over 50. And of course, equals to p here. We cancel p out. Okay. So this p, we cancel this p. That is why we are doing the division. Okay. So now this is indices. Just as when you have y cubed divided by y squared. Of course, you're going to have y as your answer because this one appears 3 times, this one appears 2 times. So 2 times, we cancel 2 times here, it remains 1 time. Okay? So that is the same thing that we have here. This expression appears 3 times, this one appears twice. So we now have, so this expression, this particular expression now, alright, this expression, we cancel this one here. Of course, you're going to have it 1 time appearing. So you now have it as what will remain is 1 plus r over 100. Okay? Over 100, that is what is remaining. Raised to power 1 because they have cancelled 2 out of it. So you now have it as 1 plus r over 100 remaining. And of course, what do we do next? We can multiply both sides, clear the fraction by multiplying by 100. Okay? Clear fraction by multiplying both sides by the LCD, which is 100. So when we do that, what do we have? When we clear fraction, we're going to have 100 into 54 divided by 50 is equals to our right hand side, 100 multiplied by our right hand side, 1 plus r over 100. That's what we have. And of course, 50 we cancel 100 remains 2 times 54. You have 108 equals to, using 100 to expand, 100 is equal plus times this one, of course, 100 we cancel 100 remain r. Okay, if you collect like terms, this one go over there, 108 minus 100 is equals to our r. So what is our r? Our r is equals to 8% per annum. So we are getting our r. So now we can have our r. We can now go and put in any of the equations. So we can say put r into equation 1. Okay, put our r into equation 1. And what is equation 1? If we refer back to equation 1, our equation 1 says 500 equals to the expression there. So we have 500 is equals to p into 1 plus r over 100 all square. So when we substitute that, we have 500 is equals to p into 1 plus 8 over 100 all square. So 8 divided by 100 is 0.08, right? Plus 1, you have 1.08, you have it all square. So 500 is equals to p into 1.08 all square. Detach this one from p because you're looking for p. So you divide both sides by this expression. So p is equals to 500 divided by 1.08 all square. And with your calculating device, we can now say that therefore our p is approximately equals to 429 naira. So this is the approximate value. Actually, what will give you 428.6 something. So this is the approximate value of the answer. Any question? Any question? All right. Well understood. Thank you. Perfect. So let's look at example 6. In example 6, it says, a woman borrowed 500,000 naira from an investment bank to start her company and pays interest at 12% per annum, compound interest. If she repays 100,000 at the end of each year, how much does she still owe at the end of 3 years? All right, so here we are. This is a question that is being compounded every year. All right, it is compounded every year. No doubt about that. Don't have a problem with that. The rate is constant. All right, one may quickly think, okay, the rate is constant. Okay, we are going to use amount is equals to p into 1 plus r over 100 raised to power n. The equation 1 of the compound interest. Of course, my brother, my dearly beloved sister, you are wrong. We can't apply this formula now because there is something that is deviating from this formula. This formula was derived based on the fact that the beneficiary don't get anything within the investment period. He or she gets his total profit added to the original principal as an amount returned to him once. That is when we use this formula, even though the rate is constant, all right? But in this question, we are told that if she repaid 100,000 naira at the end of each month, that 100,000 naira is not the interest, okay? If it's the interest, of course, we are back to simple interest, because simple interest is when the interest is being returned, as I mentioned earlier. Okay, so the woman is returning a certain amount of money, all right? So because of that amount of money that she's returning, which is no longer up to, or it may be shorter than the interest, or more than the interest, because of that, this formula has failed us. Because if it was the interest that is being compounded, then we can use this formula. It is being compounded, we have no doubt. But they have told us that she is returning 100,000 naira at the end of each year. And because of this fact, then it means that there is problem, because it's no longer normal. There is problem. The rate is constant, quite all right. But because she is returning part of the money, so here is the thing. If she returns exactly the interest, we are back to simple interest. If she does not return at all, then we have this formula to use. That is the normal compound interest. But this one, she is returning some part of money, which is neither the interest to bring us to simple interest, nor is she compounding everything that she made to make us to use formula. So you cannot see that we can no longer use this formula. So we cannot use this equation 2, neither can we use equation 1. So what we now do is to analyze this question in a period-wise fashion. Okay, we now solve this problem in a period-wise fashion, looking at each year, what is happening every year. All right, because at the end of the first year, we now know what happens. She will not know the interest that has been generated, and from there, we'll now add it to the total amount to have what we are going to use to calculate the next year. But before we now calculate for the next year, we now have to remove the 100,000 naira. That will not tell us what you're owing the company, and now calculate the next year based on what you are owing the company. All right. So this question actually deviates from the normal norm. So equation 1 is useless. Equation 2 is useless. We return to first principle and solve this problem. All right. All right. So here we go. Let's start. So we say first year. Okay. So we now say our first year, what is happening in the first year of the investment at the end of the first year. So she borrowed 500,000 naira. So the principal from the company, you want 400,000 naira, and the rate is 12%, which is fixed per annum. All right. So simple interest. So the interest for that year is going to give us. So since it's just for 1 year, so the type is 1. PTR over 100 is equals to 500,000 in the standard form is 5 exponent 5, all right, multiplied by the time, which is just for that particular year, because talking about the first year, we are looking at only 1 year. We want to solve this problem year by year, so the time is going to be 1 multiplied by 12, okay, divided by 100. All right, so when we evaluate this with a calculating device, the interest that she's expected to return to the bank where she borrowed this money is now 60,000 naira. All right. Okay. So the amount that this company will have now is going to give us amount is I, okay, plus P. So at the end of the 1 year, they are having our P 500,000 naira. So we're going to have 560,000 naira. So this is what the company is expected to have at the end of 1 year. So under normal compound interest, and it is normal compound interest, this money was supposed to be invested in the second year. Okay, which we couldn't have been following this long procedure, but I just use the compound interest formula equation 1 and solve this problem. So this is what is supposed to be reinvested in the second year, but she is returning 100,000. The question says if she repaid 100,000 naira at the end of each year. So we now say she repaid 100,000 naira. So if she repaid 100k, all right, is she still owing the company this amount? No, of course. Now says that the active principal now, all right, what will be the active principal now? The investable amount, okay, the investable amount now for the second year, okay, is going to give us 560,000, okay, minus 100,000, and of course that will give us 460,000 naira. So this is now the active principal, the investable amount for the second year. So we now say second year. So we have finished the analysis for the first year. So the second year. Now for the second year, the principal is no longer 500,000 naira, but this is what the company is owing the company now. So their profit or interest is going to be calculated based on what the woman now is owing them. So the principal now is 460,000 grand. All right. Okay. So and of course the rate is constant. So the rate is 12% per annum. All right. That is the rate. All right. So we now say simple interest again is equals to PTR divided by 100, and that will give us 460,000. Okay, multiplied by the time is 1 for that particular the second year, so it's still going to be 1 because there's only one year. So don't go and use 2, and the rate is 12 divided by 100. And with our calculating device, our simple interest, if you do this, what do we have? We are going to have 55,000 naira. So do you see that the interest of the company has dropped because their investable amount dropped also? All right. So this is what the company has. Remember, they invested this amount in the second year, 460,000, and they made a profit of this. All right. So that means their total money in the hand of the woman. So now say their amount. The total amount of the amount in the hand of the woman is going to give us I, okay, plus P, and that will give us 460,000, okay, plus 55,000, I'm sure, okay, plus 55,000, okay, yeah, that's correct. So plus 55,000, okay, that is okay, that's 55,200, all right. Alright, so it's 55,200. Okay. 55,200. That's correct. Thank you for that correction. Alright, so now if we add everything together, what do we have here? So after adding the amount is going to give us 515 200,000 naira. So this is the amount in the hand of the woman, okay, but she repaid now at the end of the second year, but she repaid how much now? She is repaying 100 grand every year, so she repaid 100,000 naira, okay, so she is repaying 100,000 grand every year. So that implies the investable amount that's going to remain now. So investable amount, what will be the investable amount? The investable amount will now be, okay, 515 200 minus 100,000 naira, and when we do this subtraction, their investable amount is 415,200 bucks. All right, so this is what is now remaining for the company that they can invest in the third year. So we now say year 3. Okay, in the third year, their principal, of course, is the investable amount, which is 415, okay, 200, and the rate is also the same, which is 12%. All right, so when I say from our principal, our simple interest, which is equal to PTR over 100, okay, and that will give us what now? 415,200, 415,200 multiplied by 1, the time is 1, multiplied by the rate is 12, and over 100. And of course, if we simplify this now, we get 49,000. Somebody confirm this. We get 49,824 grand. Okay, so that's what we end up getting. All right, so this is their interest in the third year. So the amount of the company now, the total amount after the third year is going to give, okay, what was their last investable amount, P, is going to give us I plus P, and of course the last active principal is 415, so we have 49824 plus the I is what? 49. Sorry, the P is 415,200. And of course, when we simplify further, what do we have? Okay, that's correct. We end up having 465. So we have 465,024. All right, so this is what we have as the amount of the company. All right, so after the third year. Now, but she will still have to pay the company, you know, $100,000 at the third year. All right, so let's say she repays, okay? She repays what? How much? 100,000 naira again at the third year. That implies the money now left. So we now have the final leftover that she's still owing. Will now give us 465,024, okay, minus 100,000 naira, and of course, when we simplify this, she will still be owing the company. Somebody confirm this. 365,024. Okay, thank you very much. All right, that's correct. So this is what she will be owing the company after the end of the third year. All right. So do you see how I have solved this problem in a period-wise fashion? Okay. I did not use the first equation because it does not conform to the first equation. I didn't use the second equation because the question does not conform to the second equation of compound interest. Okay, so we are only left with first principle, going back to the very meaning and understanding of compound interest and trying to analyze the problem in a stepwise or period-wise fashion, so that we can take account of what is happening in every year. All right, so that is how we solve some questions of this nature that do not conform to either equation 1 or equation 2 of the compound formula. Of course, which one is your answer? Okay, these are essay. You can as well pause the video also to look at this question. Of course, the ROS here is the unit of this morning. All right, the ROS here is the unit of the morning. Okay, just as we have naira, we have dollars. Of course, this ROS is the unit of the money. Okay, so this is the essay question 1 to 3. All right. This is the fourth one, a sum of money put loan on compound interest, record yearly amount to that, and of course in 2 years, and to that in 3 years. So we have some similar questions. These are for you to practice with. It is a good buy for me. Do not forget, subscribe to this channel. Thank you. See you in episode 4.